Close your eyes and picture a lone spacecraft, drifting through the vastness of space, lost its mission long since completed. Suddenly, out of nowhere, it transmits something absolutely chilling back to Earth. This is exactly what happened with the iconic space probe Voyager 1. The Voyager 1, humanity's farthest-reaching probe, has made a chilling discovery. And now, it's turning its gaze back towards our planet, leaving us all wondering what could it have possibly found out there in the darkness of interstellar space. Could it be proof of extraterrestrial life? Or perhaps, even more mind-bendingly, a cosmic anomaly? The probe is coming back home after 4 decades, and the secrets it's bringing with it are bound to change the course of history. A dream beyond stars. Long before its triumphant journey through the cosmos, the Voyager twins were merely a spark of inspiration, a bold idea conceived in the minds of visionary scientists and engineers. From humble beginnings to soaring heights, the story of Voyager's conception is a testimony to the power of human ingenuity. Our story begins in the early days of the 1960s, a time of vast possibility, excitement, and ambition in the field of space exploration. The thrill of earlier space missions had ignited a burning desire within the hearts of scientists and engineers everywhere. They dreamed of pushing past the limits of what we could see, of traveling beyond our solar system and into the unknown depths of interstellar space. And among these dreamers were the daring visionaries at NASA's Jet Propulsion Laboratory, led by none other than the legendary physicist Dr. Carl Sagan. Drawing on decades of collective expertise and driven by a relentless curiosity about the cosmos, this team embarked on an epic quest to design and construct spacecraft that could journey to the farthest reaches of our universe and beyond. At the heart of the Voyager mission was a team of brilliant minds at NASA's Jet Propulsion Laboratory JPL, led by the esteemed physicist Dr. Carl Sagan, with an audacious dream to push the boundaries of space exploration further than ever before. The Voyager mission wasn't just about exploration, it was about discovery on a scale previously unimaginable. With meticulous planning and relentless determination, the team at JPL set out to create robotic probes that would revolutionize our understanding of the universe. Along the way, they encountered a myriad of daunting challenges that tested their ingenuity and resolve, adding to the excitement and thrill of the mission. Get ready to embark on a journey of discovery to the unknown corners of the universe, fueled by innovation and a passion for exploration. Celestial fate. Did you know that around 60 years ago, something truly remarkable happened in our solar system? A rare planetary alignment occurred among the 4 largest planets in our system: Jupiter, Saturn, Uranus, and Neptune. This alignment was so significant that it had last occurred during Thomas Jefferson's presidency in the early 19th century. It was Gary Flandreau, a doctoral student in aeronautics at the California Institute of Technology, who recognized its importance in 1965. Flandreau, who was working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, had the extraordinary task of figuring out the most efficient way to send a space probe to Jupiter, or even farther out to Saturn, Uranus, or Neptune. Picture Gary Flandreau, hunched over his desk, pencil in hand, plotting the orbital paths of the 4 giant planets. It was a painstaking process, but one that ultimately led to an incredible discovery. Flandreau realized that in the late 1970s and early 1980s, a rare planetary alignment would occur, allowing a spacecraft to visit all 4 planets in a single mission. By using the gravitational pull of each planet to slingshot itself to the next, the journey time from Earth to Neptune could be cut from 30 years to just 12 years. There was just one catch: this alignment only occurred once every 176 years. Flandreau's visionary calculations meant that a spacecraft would need to be launched by the mid-1970s to take advantage of this once-in-a-lifetime opportunity. NASA didn't hesitate, building 2 spacecraft to make the journey. And so, Voyager 1 and Voyager 2 were launched on an incredible mission to explore the outer planets of our solar system. Thanks to Flandreau's meticulous work and the alignment of the planets, the Voyager twin probes were able to embark on an epic journey that revolutionized our understanding of the universe. It's a story that still captures the imagination today. The ingenious design. This ambitious dream, championed by visionaries like Carl Sagan, turned out to be a lot tougher to bring to life than anyone initially thought. The Voyager twins, the spacecraft that turned this dream into reality, faced a multitude of challenges from the get-go. First and foremost, designing a spacecraft that could survive the extreme conditions of space was no small feat. The Voyager probes had to withstand freezing cold, blistering heat, deadly radiation, and the vast emptiness of space without missing a beat. It was a daunting task for engineers who had to come up with advanced materials and insulation to protect the delicate instruments and electronics on board. Building a spacecraft capable of journeying across our solar system and beyond was daunting. The Voyager team had to develop sophisticated propulsion systems that could navigate the complex gravitational fields of multiple planets. But that's not all. Voyager also needed to capture detailed images and data from distant worlds. This meant designing instruments like cameras and spectrometers that could withstand the harsh conditions of space travel while delivering accurate and reliable data about the planets, moons, and other celestial bodies they would encounter along the way. It's incredible to think about the level of precision and care that went into creating these instruments. And let's not forget about the logistical challenges. To maintain contact with the Voyager probes as they journeyed farther and farther from Earth, the team had to coordinate a complex network of tracking stations and communication systems. This required careful planning and coordination on a global scale. The fact that they were able to achieve seamless communication and data transfer across such vast distances is a testament to the incredible teamwork and dedication of the Voyager team. This feat took a team of dedicated individuals, fueled by an unbreakable sense of purpose and driven by an unshakable belief in the importance of their mission. They were faced with a daunting task, but they pressed on, undeterred. Why? Because they knew that Voyager was more than just a spacecraft. It was a symbol of humanity's unrelenting thirst for knowledge, carrying with it the dreams and aspirations of countless individuals eager to unravel the mysteries of the universe. Despite the enormity of these challenges, the team at JPL refused to back down. They were determined to overcome each obstacle in their path, drawing on their collective expertise, innovation, and sheer grit. And boy, did they deliver. This symbolized humanity's relentless thirst for knowledge, carrying the dreams and aspirations of countless individuals eager to uncover the mysteries of the universe. What's even more impressive is that Voyager 1 and Voyager 2, the two spacecraft that led this charge, are still out there, exploring the cosmos to this day. They're equipped with a suite of scientific instruments that allow them to venture farther than any other spacecraft has gone before. Their longevity is a testament to human ingenuity and the power of perseverance. It's hard not to feel inspired by what this team accomplished. Did you know that the Voyager 1 and Voyager 2 spacecrafts are powered by radioisotope thermoelectric generators (RTGs), which use plutonium-238 as their fuel source? These incredible space probes carry 3 RTGs each, which convert the decaying plutonium-238 into electrical energy to power the spacecraft's operations. The Voyagers were equipped with RTGs as solar energy is insufficient at their current distances from the Sun. In fact, the Department of Energy provided these RTGs, which have been crucial to the success of the missions. Another crucial source of energy is the energy output generated at launch. But that's not all. The Voyagers also carry a highly sensitive particle detector called the Cosmic Ray Subsystem (CRS), which can detect very energetic particles in plasma. It has the highest sensitivity among the 3 particle detectors on the spacecrafts and observes the passage of super-energetic particles. The CRS was installed to measure the energy spectrum of electrons, analyze energy spectra and elemental composition of cosmic ray nuclei, and contribute to understanding cosmic ray origins, nucleosynthesis, and interplanetary transport. It also studies particle charge composition in the magnetospheres of Jupiter, Saturn, Uranus, and Neptune. A high-gain antenna HGA was also installed that transmit data to Earth via 2 frequency channels. The X-band channel, at around 8.4 GHz, carries both science and engineering data, while the S-band channel, at around 2.3 GHz, contains only engineering data related to spacecraft health. X-band data rates can reach up to 7.2 kilobits per second. And let's not forget about the other advanced instruments on board. The Voyagers also have television cameras used for imaging planets during the prime mission, infrared and ultraviolet sensors to detect thermal radiation and study planetary atmospheres, magnetometers to measure magnetic fields around planets, plasma detectors to observe charged particles in space, and cosmic ray and charged particle sensors to study cosmic rays and energetic particles. It's safe to say that the Voyager twins are well equipped with some of the most advanced technology way ahead of their time. Unfortunately, the output of the Voyager's instruments has gradually degraded over time. If the degradation continues, by 2025, there may not be enough power for scientific equipment, which could mark the end of the Voyager's scientific operations. With the first launch, imagine a spaceship traveling billions of miles away from Earth, taking us on a journey through the vast and unknown regions of space. This is the incredible story of Voyager 1, a spacecraft that embarked on a grand tour of the outer planets, beginning with a flyby of Jupiter in 1979. After years of meticulous planning, tireless preparation, and overcoming countless obstacles, the day of reckoning finally arrived. On September 5, 1977, Amidst a flurry of anticipation and excitement, Voyager 1 was poised for liftoff at Cape Canaveral, Florida on a mighty rocket known as Titan III-E or Centaur. After years of careful planning, tireless preparation, and overcoming countless obstacles, the big day finally arrived. On September 5, 1977, amidst a buzz of excitement, Voyager 1 was ready for liftoff at Cape Canaveral, Florida, strapped to the mighty Titan III-E rocket, or Centaur. With a thunderous roar, Voyager 1 broke free from Earth's gravity, shooting skyward on a pillar of flame and smoke. For those lucky enough to witness it firsthand, it was a sight to behold, a triumph of human ingenuity and perseverance. But the journey had only just begun. In the months and years that followed, Voyager 1 embarked on an epic journey through the outer planets, starting with a flyby of Jupiter in March 1979. As it neared the gas giant, its instruments sprang to life, capturing stunning images of Jupiter's swirling storms, intricate cloud patterns, and mysterious moons. Next up was Saturn. In November 1980, Voyager 1 soared past the ringed planet, sending back breathtaking images of its majestic rings. The images beamed back to Earth were nothing short of mesmerizing, revealing the intricate structure and delicate beauty of Saturn's rings in unprecedented detail. Voyager 1 didn't stop there. With each passing milestone, it pushed the boundaries of exploration, venturing farther and farther from home. When it crossed the heliopause, the boundary marking the edge of the solar system, Voyager 1 made history once again, becoming the first human-made object to enter interstellar space. Throughout its epic odyssey, Voyager 1 captured the hearts and imaginations of people around the world, sparking a renewed passion for exploration and discovery. Its images and discoveries inspired awe and wonder, reminding us of the boundless beauty and mystery of the cosmos. One of Voyager 1's most thrilling discoveries came during its close encounter with Jupiter in 1979. As it passed just 349,000 kilometers from the gas giant, it captured unprecedented images of Jupiter's turbulent atmosphere, including the iconic Great Red Spot, a storm system larger than Earth itself. But the surprises didn't end there. Voyager 1's flyby of Jupiter also provided scientists with invaluable data about the planet's moons, including Io, Europa, Ganymede, and Callisto. From the volcanic eruptions of Io to the icy plains of Europa, each moon offered tantalizing clues about the diversity and complexity of worlds beyond our own. Continuing on its journey, Voyager 1 set its sights on Saturn, where it made yet another series of groundbreaking discoveries. In 1980, the spacecraft captured mesmerizing images of Saturn's majestic rings, revealing intricate patterns and structures never before seen by human eyes. These images not only captivated the public but also provided scientists with invaluable insights into the dynamics of Saturn's ring system and the processes shaping its evolution over time. But perhaps Voyager 1's most profound discovery came in 1990, long after its primary mission had ended. From its vantage point nearly 6 billion kilometers from Earth, the spacecraft captured an iconic image known as the pale blue dot, a poignant reminder of our planet's fragility and insignificance in the vastness of space. This image, inspired by the words of Carl Sagan, continues to resonate with people around the world, serving as a humbling reminder of the interconnectedness of all life on Earth. As Voyager 1 ventured ever farther from home, it continued to push the boundaries of exploration, providing scientists with valuable data about the outer reaches of our solar system and beyond. From its historic entry into interstellar space in 2012 to its ongoing mission to study the distant reaches of the galaxy, Voyager 1 remains a testament to the power of human curiosity and the enduring spirit of exploration. The launch that followed. Imagine joining an incredible cosmic adventure just 15 days after Voyager 2 blasted off on August 20th, 1977. Voyager 1 may have stolen the spotlight, but its twin, Voyager 2, embarked on its own remarkable odyssey through the cosmos, unearthing a wealth of discoveries along the way. In 1979, Voyager 2 wowed the world with its close flybys of Jupiter. It captured stunning images of the gas giant's swirling storms and intricate cloud patterns, and provided unprecedented insights into its moons. We got to see Io's fiery volcanic eruptions and Europa's mysterious icy surface up close for the first time. Voyager 2 didn't stop there. It set its sights on Saturn next, making groundbreaking discoveries in 1981. The spacecraft revealed the intricate structure of Saturn's rings in amazing detail, shedding light on their composition and dynamics. Voyager 2's observations gave us new perspectives on Saturn's atmosphere and magnetic field, helping scientists understand the forces shaping the planet and its moons. But wait, there's more. In 1986, Voyager 2 made history with its flyby of Uranus, becoming the first and only spacecraft to visit this icy giant. During its encounter, it captured images of Uranus's atmosphere and moons, including Miranda with its dramatic surface features and diverse geological formations. Talk about a cosmic show. Voyager 2 continued its journey, making its final planetary encounter with Neptune in 1989. It provided humanity with our first up-close look at this distant ice giant. The spacecraft's observations revealed Neptune's dynamic atmosphere, featuring the iconic Great Dark Spot and swirling cloud patterns, as well as its complex system of rings and moons. What a way to cap off its planetary tour. But the adventure didn't end there. Like Voyager 1, Voyager 2 continues to venture through interstellar space, sending back valuable data about the environment beyond our solar system. From its measurements of the solar wind to its observations of cosmic rays and interstellar gas, Voyager 2's mission continues to yield valuable insights into the nature of the universe and our place within it. Voyager 2 may have started its journey in the shadow of its twin, but it has carved out its own legacy, proving that the cosmos is big enough for both spacecraft to shine brightly. Their ongoing missions remind us of the endless curiosity and indomitable spirit that drive us to explore the great beyond. The success of the Voyager twins. The Voyager twins, originally tasked with exploring the gas giants of our solar system like Jupiter and Saturn and their numerous moons, ended up doing so much more. These fearless space travelers went above and beyond, surpassing all expectations by venturing farther and lasting longer than any spacecraft in history. They shattered records on their awe-inspiring odyssey, traveling beyond anything humans had ever created, even entering the uncharted territory of interstellar space within our galaxy. Today, Voyager 1 and Voyager 2 are more than 12 billion miles away from us. Despite this immense distance, they continue to amaze scientists with their remarkable discoveries. Recently, they made a discovery so unexpected that it took everyone by surprise. Over 40 years ago, when Voyager scrutinized the moons of Jupiter and Saturn, scientists initially thought they would be dull and pockmarked like our moon. Instead, these moons turned out to be vibrant hubs of activity. In 1986, Voyager 2 made history as the first of the twins to swing by Uranus, and just 3 years later, it zipped past Neptune, a feat unmatched by any other spacecraft. As these incredible spacecraft continue their journey, NASA has employed some clever strategies to keep them operational. They've deactivated non-essential components like spare parts and heaters to conserve power, aiming to keep them running smoothly until at least 2030. For the dedicated scientists and engineers who have been part of this extraordinary adventure from the beginning, these probes have achieved some truly remarkable feats. The Voyager missions were a remarkable achievement in space exploration. They provided researchers with the first up-close views of the moons of Jupiter and Saturn, revealing them to be vibrant worlds. Voyager 1 and Voyager 2 were equipped with VidCon cameras using filters to capture full-color images. Interestingly, they were designed to be very stable, spinning through space at a rate more than 15 times slower than the hour hand of a clock, ensuring clear and sharp images. During their mission, the Voyagers took over 33,000 photographs of Jupiter and its moons, each revealing new and fascinating details. For instance, Europa, one of Jupiter's 53 named moons, was found to have a cracked icy crust estimated to be more than 60 meters thick. As the spacecraft departed from the Jupiter system, they received a farewell boost in speed of 35,700 mph from a gravitational slingshot, a crucial maneuver that helped propel them towards interstellar space. At Saturn, the Voyagers went their separate ways. Voyager 1 passed through Saturn's majestic rings, enduring thousands of impacts from tiny dust particles before flying past Titan, a moon enveloped in an orange haze, and then heading northward out of the plane of the planets. Voyager 2 continued its solitary journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Voyager 2 discovered 10 new moons and confirmed that Uranus also had rings. However, Voyager 2's achievements were overshadowed by tragedy when, just 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after liftoff, claiming the lives of all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian to travel into space. 3 years later, as Voyager 2 soared about 2,800 miles above Neptune's stunning azure methane sky, it encountered the swiftest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 mph. Neptune's largest moon, Triton, turned out to be one of the coldest spots in our cosmic neighborhood, with surface temperatures plunging to a staggering minus 235 degrees Celsius. The moon's icy volcanoes were another remarkable find, ejecting nitrogen gas and fine particles up to 5 miles into its atmosphere. The story of Voyager 1 and Voyager 2 is one of incredible achievements and enduring exploration. These spacecrafts continue to push the boundaries of what we know, sending back data from the farthest reaches of space and inspiring generations with their journey. Their missions remind us of the boundless curiosity and unyielding spirit that drive us to explore the universe. Mission extended. After Voyager 2's mesmerizing images of Neptune and its moons, it was time for both spacecraft to power down their cameras, signaling the end of their official mission. But astronomer Carl Sagan, a key member of the mission's imaging team, had other plans. Even though the grand tour was technically over, NASA extended the mission in hopes that the Voyagers would venture into interstellar space. Renamed the Voyager Interstellar Mission, these spacecrafts were set to continue their journey into the unknown. Sagan, always the visionary, persuaded NASA to let Voyager 1 take one last series of images. On Valentine's Day in 1990, Voyager 1 turned its cameras back toward the inner solar system and snapped 60 final shots. Among these was the now famous pale blue dot capturing Earth from an astounding distance of 3.8 billion miles. In the picture, Earth appears as a tiny speck, barely visible against the vastness of space, illuminated by a faint glimmer of sunlight reflected off the camera's optics. It's a humbling and poignant reminder of our place in the universe. We've learned so much about the planets and moons in our solar system. Each one is unique and fascinating, even those that are farthest away. In August 2012, Voyager 1 achieved an incredible milestone by venturing beyond the heliosphere, a vast region of charged particles emitted by the sun. This remarkable feat was confirmed the following year when a study published in the Journal of Science shared Voyager 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a powerful solar eruption between April 9th and May 22nd, 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found just inside the heliosphere. It might seem surprising that electron density is greater in interstellar space than near the Sun. However, researchers explained that the electron density at the edge of the heliosphere is significantly lower than at Earth's surface. By analyzing Voyager 1's data, researchers pinpointed the official departure date as August 25, 2012. This determination was not based solely on electron oscillations, but also on measurements of charged solar particles collected by the spacecraft. On that significant day, coinciding with this electron oscillation, Voyager 1 left the heliosphere and entered interstellar space. The adventures of Voyager 1 and Voyager 2 continue to amaze and inspire us. Their journeys remind us of the boundless curiosity and unyielding spirit that drive humanity to explore the universe. As these intrepid explorers sail through the cosmos, they keep sending back invaluable data, providing us with a deeper understanding of the vast and mysterious universe we call home. The Voyager 1 problems. Get ready to be amazed by the incredible Voyager 1 spacecraft. Voyager 1 is equipped with 3 onboard computers, including a flight data system that gathers information from the spacecraft's scientific instruments and bundles it with engineering data to keep tabs on Voyager 1's health. This data is then sent to mission control on Earth and binary code a series of ones and zeros. Recently, though, Voyager 1's flight data system seems to have gotten stuck in a loop, sending the same pattern of ones and zeros back to Earth over and over. This hiccup was first noticed on November 14th, when the spacecraft's telecommunications unit started acting up. Although Voyager 1 can still receive and execute commands from mission control, the problem means that no new scientific or engineering data is coming back to Earth. NASA engineers have tried restarting the flight data system, but so far, no usable data has been received. They are now working to figure out the root cause of the issue before deciding on the next steps to fix it. This process could take several weeks. Interestingly, this isn't the first time Voyager 1 has had issues with its flight data system. A similar problem popped up back in 1981. However, the current glitch doesn't seem related to any other issues the spacecraft has encountered in recent years. As the Voyager probes continue their epic journey, facing new challenges, the mission team is relying on manuals written decades ago for guidance. These old-school manuals, while thorough, couldn't have predicted all the challenges the spacecraft would face as they journeyed through the cosmos. The team is being super careful, thinking through all the potential implications before sending any more commands to Voyager 1 to make sure its operations aren't unexpectedly impacted. In a way, it's like a cosmic detective story. The team sifts through decades-old notes and uses their problem-solving skills to keep this incredible spacecraft going. It's a testament to the ingenuity and persistence of the people behind this mission, who continue to support Voyager 1 as it ventures farther into the unknown. Voyager 1 is so far away that it takes a staggering 22.5 hours for signals to travel from Earth to the spacecraft. And that's not the end of it. Add another 22.5 hours to get a response back. So we're talking almost 2 days just to hear back from a spacecraft. As the Voyager twins continue their epic journey through space, the team has had to make some tough calls to keep them going. They've started turning off some instruments on these aging probes to save power and extend their missions. Both spacecraft have faced unexpected problems along the way. For instance, there was a 7-month period in 2020 when Voyager 2 couldn't communicate with Earth. But in a stroke of luck and ingenuity, the team managed to restore communication in August by using a clever technique to realign the spacecraft's antenna. While the team is hopeful about restoring the regular flow of data from Voyager 1, the real value of these missions lies in their longevity. Scientists are eager to study how particles and magnetic fields change as the probes venture farther from the heliosphere. However, this invaluable data set will be incomplete if Voyager 1 can't send the information back. The team has also been innovative in finding ways to extend the power supply on both spacecraft. The Voyager missions have far surpassed their initial expectations, despite the challenges they faced. These spacecrafts have outlasted any other in history. While engineers are working tirelessly to keep them going, they know that more challenges may lie ahead. The voyages of these spacecraft are far from over. Reaching interstellar space is one thing, but reaching the farthest reaches of our solar system is another. Imagine the solar system as a balloon, with a cloud of comet-like objects called the Oort cloud held in place by the sun's gravity. This Oort cloud might stretch halfway to the nearest star, and it will take the Voyager probes about 300 more years to reach its edge. When we talk about interstellar space, we mean the region beyond where the solar wind, those charged particles and magnetic fields streaming from the sun stops. Think of the solar wind as air blowing up a balloon, creating the heliosphere, a protective bubble around our solar system. This bubble is eventually halted by the pressure from interstellar matter, forming a boundary known as the termination shock. The border between our solar system and interstellar space is called the heliopause, and it's pretty far out there. Initially, some thought it might be as close as Jupiter, but better calculations in 1993 put it around 25 times the distance from Earth to the Sun, which is 1 astronomical unit (EU). Voyager 1 hit this boundary about 20 years after those calculations, detecting a rise in plasma density. Voyager 2, on the other hand, reached the edge of interstellar space in 2018, but didn't observe any changes in the magnetic field. This was surprising, because theories had predicted fluctuations tied to the Sun's 11-year cycle. When Voyager 2 arrived, the solar wind was at its peak, challenging these predictions. With real data from the Voyager probes, scientists are now refining their models of how the heliosphere interacts with interstellar space. In simpler terms, our Sun has moved from a hot ionized zone into a partially ionized section of the galaxy. The hot zone probably formed when nearby ancient stars exploded in supernovae, heating the space and affecting nearby atoms. It's like being at the seaside with swirling waves and water. Things get a bit chaotic near the heliopause. Magnetic fields twist and turn in unexpected ways, rather than following the smooth pattern scientists had imagined. The Voyagers discovered a lively environment filled with lots of small changes, even though they didn't spot significant differences in magnetic fields on a larger scale. Eventually, these spacecraft will move beyond this chaotic region and encounter the pure magnetic field of interstellar space. As we continue to follow these amazing spacecraft, it's important to note that both Voyager probes are still operational, thanks to a system that converts heat from plutonium's decay into electricity. However, their power output decreases by about 4 watts each year, putting the mission team in a tricky situation. While it's thrilling to watch the Voyagers continue their journey, the day is coming when we'll have to say our goodbyes. Despite this, the probes will keep exploring even if they can no longer communicate with us. Voyager 1 is set to pass by Proxima Centauri, our neighboring star, in an incredible 16,700 years, with Voyager 2 following about 3,600 years later. A strange discovery. Voyager 1, a spacecraft that has been exploring space for nearly 45 years, has recently picked up a peculiar humming noise from beyond our solar system. Stella Cooch, a student at Cornell University, and her research team discovered this odd sound in data from Voyager's plasma wave system, which measures electron density in space. Although the humming is quiet and repetitive, it has left scientists scratching their heads. They believe this discovery could shed light on the workings of space beyond our solar system and its interaction with the sun's influence. Could this humming sound hold the key to understanding how the gas in space is affected by the sun? Even though Voyager 1 has been an incredible asset for space exploration, it's recently given NASA a bit of a headache. The spacecraft's attitude control system and antenna aren't sending back the correct data, even though they seem to be functioning properly. The data received is all jumbled up. Despite this hiccup, Voyager 1 can still receive and execute commands from Earth. Suzanne Dodd, who leads the Voyager mission team, is confident they'll get to the bottom of this issue and fix it. One of the most fascinating aspects of the Voyager probes is their use of an ancient 8-track tape system, yes. The same kind of tapes that were all the rage in the 70s. It's amazing to think that these probes are still relying on such old technology, but it really showcases the brilliance of the mission planners. They ensured that these durable tapes could still do the job, even decades later. Back in the early days of space exploration, digital storage was just emerging, so engineers needed something robust and reliable to store the valuable data collected by Voyager. Those 8-track tapes turned out to be perfect. And what kind of data do they store? Not just your favorite 70s hits, but crucial scientific information about planets, moons, and the vast space between the stars. These tapes hold the keys to unlocking some of the universe's greatest mysteries, making them incredibly valuable. Voyager 1 has been on a historic journey since its launch, surpassing the bounds of our solar system and venturing into the unknown depths of interstellar space. As it cruised through the silent expanse, its sensors picked up something unexpected: a faint, strange humming noise resonating from the very fabric of space. Scientists at NASA were puzzled. What could be causing this phenomenon? Was it a cosmic anomaly, or perhaps a message from a distant civilization? As they pondered this mystery, Voyager 1 made another astonishing discovery. Its cameras captured images of a vast swirling cloud of gas and dust stretching across millions of miles. Voyager 1 continued its journey, leaving behind a trail of questions and wonder. However, Voyager 1 just made a startling discovery that caused it to suddenly turn back towards Earth. Astronomers are now left wondering about the countless unknown mysteries that still lie beyond the stars. Could this mysterious discovery be the very cause of Voyager 1's unexpected change in direction? Share your thoughts in the comments below. A feat of longevity. Voyager 2 boasts 5 operational tools, while Voyager 1 has 4. Their endurance is owed to a special power source that converts the heat from decaying plutonium into electricity. Voyager 1 is set to swing by Proxima Centauri, the closest star to us, in an astonishing 16,700 years, while Voyager 2 will follow suit, albeit 3,600 years later. These intrepid travelers will meander through the galaxy for eons, outlasting our sun's demise and the vanishing of the heliosphere. Even in their silence, these spacecraft may carry a final message. They harbor 2 vintage copper records coated in gold, encased in aluminum. These records contain sounds and images depicting life on Earth, a 90-minute medley ranging from Bach to Chuck Berry and scenes of joy like children's laughter, dolphins frolicking, sunsets, and chirping crickets. They encapsulate our essence, narrating our tale to the cosmos. Jimmy Carter, the president at the Voyager's launch, appended a message expressing hope for a future where we've resolved our issues and can unite with other galactic civilizations. It embodies our aspirations, resolve, and goodwill. In the vast and wondrous cosmos, the Voyagers, silent heralds from Earth, persist in exploring the infinite expanse among the stars, bearing our narrative and our dreams of cosmic connection. The DAM detection of anomalous magnetic moment of Voyager's golden records. Nick Oberg, along with a colleague, simulated thousands of trajectories tracking the Voyager spacecraft and their encounters with cosmic dust clouds. They envisaged potential risks the golden records might encounter on their odyssey. This endeavor also pondered the prospect of a cloud's gravitational pull altering the spacecraft's trajectories. Oberg elucidated that these clouds possess such staggering mass concentration that they could warp the spacecraft's course, diverting them into new orbits, occasionally much farther out or deeper toward the galactic core. Both golden records stand a good chance of enduring, given that their engraved sides are securely nestled against the spacecraft bodies. Yet, Voyager 1's record's outer surface is more susceptible to erosion over time. Conversely, Voyager 2's record faces a greater likelihood of becoming ineligible due to its more erratic orbit, which makes predicting its environmental encounters uncertain. Despite these challenges, the Voyagers will continue exploring the cosmos, and their legacy will continue long after they have gone. Let us know your thoughts about these amazing spacecraft in the comments below. See you in the next video.